In this section, we're going to talk about linear functions, slopes, and applications. If you want to take a minute and pause this and write this information down or read over it, please do. That's our objectives for this section. So now it's telling us that if I have a linear function, now remember, the function is named either f or h or g, whatever it may be. In this case here, it's f of x. And remember, whatever the function f of x yields out, it gives me my y value. And if it's linear, then that means I'm going to have a straight line. It could be a horizontal line, a vertical line. It could be, increasing left to right, decreasing left to right. We're going to talk about those things here in just a little bit. But that's a linear function. In this case here, it's telling us if the function is written in my, here we go. There it goes. I was going to say it's not wanting to erase. There. If the function is written in the format of f of x is equal to mx plus b, we know it's a linear function. We know that m is my slope of this function, which tells me if we're rising left to right, dropping or falling left to right, or dropping left to right, however you want to call it. If it's horizontal or if it's vertical, and we'll go into detail on that. B is going to be where it crosses the y-axis. It's going to be my y-intercept, okay? It says that if my slope is equal to 1, right, it's increasing by 1 unit, whatever direction it may be going. And then my b is 0, then I get a function of f of x. And this tells me that I do not have a y-intercept because it's 0. It's actually crossing the x-axis, because remember, y is 0 on x. Unless it crosses the origin, then they're both 0. And if that's the case, well then we'd have 0 for the slope and 0 for b, and then f of x would equal 0. In this case here, it said that if my slope is equal to 0, but I do have a y-intercept, well, then I'm going to have a horizontal line, right? Because it's crossing my y-axis, and I have all values for it. So we're going to solve these, and it's going to make better sense pretty soon. So now this is giving us an example of my linear function. It's a straight line. In this case here, it's rising. It rises left to right. So this means that my slope is a positive value because it's rising. So if it rises left to right, it's positive. If it falls left to right, then it's a negative slope. If it's a vertical line, then the slope is undefined. And again, we're going to talk more about it. If it's a horizontal line, my slope is equal to 0. Okay? So these are just some examples of them. We're going to actually start solving pretty soon. So here you go. This is an undefined slope right here. So my slope is undefined. That means whatever my function's called, it's going to give me x equals. So in this case here, x is equal to 4. Oh, what happens? X is equal to 4. X is equal to 4. So the equation of this line would just be x equals that 4. On this one here, I have a horizontal line, so my slope is 0. And one way to look at a horizon, whenever you start your day, always starts at 0. So if it's a horizontal line, my slope is always 0. So my equation of this line is going to literally be, what do we got here? We got -2 for y, -2 for y. So all day long on this line, it's going to be -2 for y. So that is what my equation of the line would be. So if you're asked to write it in slope-intercept form, we'd write it in this format. Same for this one over here. Okay, so this is just explaining what I've just said. So if you want to pause it and read it. Now, whenever we're solving for the slope, it's always rise over run, which is going to be my y value over x, which is the change in y over the change in x. As you see here, they've gave you two ways of writing this. You pick the one you want to use. I always use this first method. There, my highlighter. It says y2 minus y1 divided by x2 minus x1. What is that telling me? It's telling me that I have a subscript of 2 for this first value of y in this operation here. That means it's the second order pairs where it came from. And then the y value here with the -1, or not, excuse me, -1, excuse me. The y value with subscript 1 means it came from my first order pair. So this first fraction here says I'm going to take the y value, so it's changing y, from the second order pair minus the y value from the first order pair. And then the denominator says, oh, okay, well, I'm going to take the change in x by subtracting the x from the second order pair minus the x from the first order pair. You could use that method. That's the method I always use. I stick with it. However, you have this other option. You can take the y value from the first order pair minus the y value from the second divided by the x value from the first order pair minus the x value from the second. Which one of these methods you use, you have to stick with it. You cannot flip-flop these around, okay? Again, I like the first fraction better. So now this one here says I have, oh, and there's it didn't download great. So let's just look at this right quick. It says that we have, we're going to determine, I don't like how it messed up. Okay, so let's look here at this function right here. See it? This here should have been -2/3 x plus 1. You don't have to do all this work here at the beginning. You will if you're wanting to find certain values. But in this case here, we're trying to find the slope. Well, if it's already written in this format, and remember, this y is also the same as saying f of x equals that, because f of x yields y. If it's already written in this format, you already know what the slope is. In this case here, the slope is a -2/3. And then since they already gave it to you in this format, we know what our b is, which is my y-intercept. And anytime it crosses the y-axis, x is always 0. So we know this. So we can go ahead and plot the line. Unless it asks us for more order pairs. And that's what they did here. And we'll get to that. But let's just plot that. So what I would do is plot my y-intercept first. So let's come over here where it is 1 for x and 0 for y. There we go. I plot that point. Now we are going to, let's change this to, no, let's go to green. Okay, because I'm trying to figure out where it'd be more obvious. So we're going to plot the slope from the y-intercept. All right, since, and you may want to take notes. I'm going to have to erase this. I don't know that it'll stay on the side if I write it. I'm going to try and see if it'll stay. Okay, if. We got our if statement. Okay, it won't. Let's try it. If you're, nope. Let's come over here. If your slope, okay, if it is negative, we're going to drop the slope. We're going to apply it to the y value. And then we're going to move to the right for the x. If it's positive, we're going to increase the y value and move to the right for the x. There's another way to do it, but this here is so consistent. X always moves to the right. You can flip-flop it, but just remember there's an extra step in the other method. So in this place here, it's a negative value. So I'm going to start here at my y-intercept. And my x value, or excuse me, my y value is a -2. So I'm going to go down 1, 2. And then I'm going to move to the right, my x value, which is 3. 1, 2, 3. There we go. From here, I'm going to go down 1, 2, because remember, it's a negative value, and then y is 2. And then I'm going to move over, oh, let's go down 1, 2, move over 1, 2, 3. Then I get this value. And you can keep going on and on and on, plotting this. And since it's a negative value, we know that the line is going to fall left to right. Now, in this one here, it asks us to plot some other points on the line without just plotting the slope-intercept form. So since it's asking for us to find other order pairs, that's where we say, oh, okay, I got this f of x is equal to -2/3. And I'm leaving a parentheses open for my x value. And it's, since in the denominator is a 3, I'm going to go ahead and plug in 3 for x. Because what happens? Well, 3 goes into 3 once, leaves me with that -2 plus that 1, which gives me -1. So my order pair is 3, -1. And I can come over here and plot that. Well, boom, that works out great. It's giving me where the slope is. And then you could plug in another value and so on. So just practice these. Again, reach out to me if you have any questions. Types of slopes. It's just showing you that if the line is slanted up, left, to the right, it's just letting us know it's a positive. So basically, anywhere's on this graph, if it could be right here in this particular point, and it's increasing left to right. It's not a horizontal or a vertical line. It's increasing left to right. It could be anywhere. You notice it's increasing left to right, so it's a positive slope. If it decreases, and it could have been anywhere on here, decreases, it's negative. Okay. This one says if it's a horizontal line, its slope is equal to 0. Again, think about horizon. The sun is rising as it starts the day. It always starts at 0, right? And it starts rising. So anytime it's the horizontal line, remember it's always 0. Now let's talk about a vertical line. So if I have a vertical line for my equation, one way to look at this is you cannot hang a picture on the wall without support. So my slope here is undefined, okay? Because you cannot hang anything on a wall without support. Maybe that will help you visualize a vertical line is always undefined slope. All right, so now when we graph this x equals -2, well, that means x is not changing. See it? But y is. And that's why we got a vertical line. If I have y equals 5/2, well, y is not changing, but x is, and that's why we get a horizontal line. So let's talk about this application problem. It says the grade of a road is a number expressed as a percent. That tells how steep a road is on the hill or mountain. A 4% grade means the road rises or falls 4 feet. For every horizontal distance of 100 feet. Okay, so that makes sense. Now let's solve. So if you're going to build a ramp, right, we need to know our rise. How much of a rise does it need to have? In this case here, it says 1. And then it says a horizontal run of 12 feet. So we want it out 12 feet. So if we wanted to rise 1, it's going to rise 1 every box until we get to the 12 feet, right? So they came up with these here. They gave us this drawing here. So this here makes sense. This would have been 1/12, right? It's rising 1 to 12. So every 12, it's rising 1 every 12. So now they said, what if we went up 3 inches? That gives me 42. This is what they're giving us. Okay, guys, this is not saying this mathematically goes with the 1/12. Anyways, they said, well, we're going to build a ramp that rises 3 inches and that runs 42 inches. So I'm going to write my slope as 3/42. The inches will reduce because inch goes into inch 1 time. And that's how come that went away. So I'm going to come over here. So now I have 3/42s, and I'm going to reduce this. 3 is prime, so I'm going to leave it alone. But I know 6 times 7 gives me 42. And I know that 6 is 2 times 3, and I still got the 7. The 3's reduced, leaving me with 1 over, because 3 goes into itself once, okay? Leaves me with 1 over 2 times 1 times 7, which is 14. Right? So now I have this, and I'm going to multiply it by 100%. And must be a typo here because they said 3 divided by 42 gave them 4. So it must be a typo here in their PowerPoints. Okay. So it is 1/14. So if I take that 1 divided by 14, I'm gonna get a really long decimal place. And I'm going to, this is what I get on my calculators. Yours might round a little sooner, okay? And then I'm going to multiply it by 100%, but there's a shortcut. If you're putting it in percent, you're going to move the decimal 2 places in this direction. So we're going to go 1, 2. So it's approximately, since it wasn't an exact number, 7.14%. If they ask you to round to the nearest tenths, it would be just 7.1%. So there's a typo in their writing here. It was left off that because their answer came out to the same as ours. So if you're ever reading any of this material and you see a typo, just let me know. Or if you're in question about it, just let me know. Okay, so their average rate of change is going to be the sum divided by the number of them. So in this case here, it says the slope can also be considered as the average rate of change. To find the average rate of change between any 2 data points on the graph, we determine the slope of the line that passes through the points. Businesses love these this method because they can determine if they're averaging an increase or a decrease over a period of time. So the number of people participating in the Federal Supplemental Nutrition Assistant Program has increased from 17.2 million in 2000 to 47.6 million in 2013. So we have 2 order pairs here. We have this order pair, and then we have this next order pair. So the graph on the following slide illustrates that. So let's go to it, and I want to show you something. So as you notice here, in 2000, it increased to 17.2, and then by 2013, it increased it to the 47.6. So I have my order pairs, and now we can determine what's our average rate of change. What I would do is just put it in my slope-intercept form. So I got my Y value from the first order, or excuse me, second order, minus the Y value from this first order pair, divided by the time, right? So if you wanted to, you can say 13, but we're going to say 2013 minus 2000. And then we're going to divide this out, right? So in the numerator, I got 47.6 minus that 17.2, which gives me a decimal, but we're going to just leave it in that format for right now, which is 30.4 over, and then 13 is my denominator, right? 2013 minus that 2000. So now I'm going to divide the 30.4 by 13. I get a fraction of 152 over 65. If I put it in decimal, it's going to be a long decimal, so I'm going to put approximation instead of an equal sign. I didn't give myself enough room to write out my number. And your calculator may round sooner than mine or later. So I get this answer right here. So let's finish this up. So they said that, oh, okay, they rounded to the nearest tenth. So let's do that. So when we round to the nearest tenths, I get an answer of, and guys, if you have questions about rounding, just holler at me. I also got a video out there on how to round. 2.3, and this is what's going to answer the question. Go back to what it asked for. It said, find the average rate of change in the number of people using food stamps between 2000 and 2013. It is 2.3 million. Because look, right here, it says million. All right, so that's solving the application problem. So then they said we can plot it on the graph. We talked about that. We have this here, just putting it in y-intercept form. So slope, y-intercepts. Oh, okay. So now they said, let's take this equation of 3x minus 6y minus 7 is equal to 0. And they want you to write it in this format. All right. So if I'm going to write it in the slope intercept form, and it says y-intercept, sometimes you're just going to see slope intercept. Okay. When I do that, what I need to do is get the x values on the other side and the constants. Well, let's start with the constant. I have a -7 here. I'm going to add it to both sides. So now I have 3x minus 6y is equal to 7. Now I want to get the x on the other side. Since it's positive, I'm going to subtract it. Now I have -6y is equal to -3x plus that 7. And let's divide by this -6 because that's going to be the only way you can get a +1 coefficient. As you notice, it's a +1. We just don't write it on the y value or the x value when you're solving for them. In this case here, we're solving for y. And division undoes multiplication. Negative divides negative gives me a positive. 6 goes into 6 one time, and that's where it's going to give me the +1 on the y. But what you do to one part, we must do to the other. So again, negative divides negative is positive. However, 3 and 6 reduces, right? 3 goes in itself once, goes in 6 twice. So now I got a half x. And then negative divides positive is negative, and 7, 6 does not reduce neatly. So I'm going to have this. If I was to make a statement what my slope is, we know that we got it written in this format. I can say it's a half. And then we got it written in this format, my b, which is my y-intercept. In this case here, since it crosses the y-axis, x is 0. And then my y value is -7, 6. Okay. And then we can graph one if we wanted to. Okay, so this one here says since the y value is negative, we move down, right? Down 2, and we move to the right 3. If the y value was positive, we would move up and still move the x value to the right. And here is some more notation. So I have m of x is equal to 0.5x plus 2.5. And then we have this function. Okay. So it's actually an application. It says that m is going to represent my male children whose parents has a height x inches. And then we have a female child whose height is in x inches. So we're going to estimate that the females are 135 inches. So we'd come back up here, and for my x value, we'd just plug in the 135 for my x, right? That's where we're plugging it in. So we get 0.5 times that 135 minus 2.5. So when we do our math here, we're going to say 0.5 times that 135. Which gives me 67.5 minus that 2.5. So it says that we have 65 children that are female at the height of 135 inches. Okay. Thank y'all.